So we are basically called Farmen because due to COVID, we are divided by nations. And due to ICT4D, we are united by farmers with the use case in hand, which is autonomous irrigation in Ghana. So yeah, moving on. This is our team, and we have quite a diverse team. Ajibola is from Nigeria, Gideon from Ghana, Vignesh and myself, Srinivas, we are from India, and basically we managed to collaborate and bring out a solution, which I'll be explaining in the further slides. So getting into the solution, I would like to introduce the problem and why are we doing this. So Gideon took the place of collaborating with the farmers and getting the inputs, and we find that there are long dry seasons in Ghana right now, and maybe in Africa as well. So getting that into account, the need of water is much more than usual for farmers. And there are systems as well, which is controlled by humans, but which ends up in forgetting. I mean, humans forget, they have the tendency to forget as well. So over there's a lot of water wastage, even when there are apps to control irrigation manually. I mean, it's done manually. The application control is done manually. So water wastage happens, which is one of the environment factors as a problem over here. And that is why our objective brings to a solution where we could create a better agriculture productivity in Ghana and also conserve water with appropriate conservation of environment as well. So letting you know a little bit of Ghana. So Ghana basically provides 37% of GDP towards agriculture, and it employs 56% of the economic population in farming, as well as about, say, 80% of smaller farmholders are involved with the agriculture production as well. And apart from that, 38% of agriculture land is basically cultivated in Ghana, and out of which 2.74 million households are involved in farming. But the only one problem which we saw was, which Gideon brought to us, was productivity was generally low, and water consumption was not really possible. So yeah, coming to the next one, there was water usage. Yeah, coming to the water usage part, 48% of water is used for agriculture, out of which 5% is groundwater, basically. This is something related to how Ghana is using water and what kind of agriculture information they have. Now, with the problem, we came to a solution as a team where Vignesh and Gideon brought us a solution and an idea behind the problem. And I was involved with the AI technology, basically, to build out a possible solution with the data in hand. So we have the data collected from the IoT hub. So like the weather conditions and the farmer's knowledge, which was really important for the context of farming, and water, and also the water level storage, and like the land conditions, like the soil types and the crop types. And apart from that, we did a data analysis. We will be doing a data analysis. Like, we need to consider what data needs to be there in order to build an algorithm for the model to work automatically without any human assistance. So then we'll be doing a pilot test in Ghana if the COVID is gone, and we'll be trying to implement in a certain farm with the help of the government and the NGOs. Coming to the AI process and the ML process, the data collection and the prediction system is the main two things which were divided here. Data collection is done with the help of the IoT company. Basically, we collect data and transfer the data to the system in the AI process, and we train the data for the system to make decisions on when the next irrigation is supposed to happen automatically, and when it's supposed to switch off automatically based on various factors like the soil and the crop types and the properties, and also weather information. And also we bring in irrigation reports, the history of irrigation, so that the model also predicts according to what has happened earlier, and also the context of farmers, the knowledge of behind farmers also adds a value to the system as well. So yes, we have done the solution and we have brought everything in, but we just analyzed that can be risk. Every product, every application has got its own risk. So our risks are basically divided into four, and we have the cost challenge. Basically, this challenge can be avoided by bringing the government and NGO to support us with the funding. And also power supply in Ghana is really bad. So in a sense, there's power cuts. So we thought of using solar energy to plant it in Ghana. So yeah, which can be a possible solution for regular power supply. for our system where internet is really necessary. And the awareness behind the system is really important before we take it to all the farmers in Ghana, maximum number of farmers. So far, we only narrowed our farmer base. We are not completely generalized. Farmers, only the commercial farmers will be able to use this. But in order for everyone to use it, we are trying to make workshops and training for all the farmers to understand the concept behind this. And every system has got a failure, and our system has got a backup system, which is called expert systems, which doesn't need really data behind it, which needs only farmers' knowledge and the rules set behind it, which is called the expert system. The farmers are the expert, and the system which runs behind that is called the expert system. And the stakeholders and their purposes for this listed here, basically the stakeholders who are involved are farmers, the IoT companies, the government, and basically we, the farming people. So the farmers, they are involved with giving us the indigenous knowledge, and also they're involved in their own business activities, as well as they're also involved in giving us the knowledge behind specific regions. Each and every region has got their own crops, own types, and own weather conditions. Apart from that, IoT companies, they are involved in giving us the right set of data and also analysis of the data. And government and NGOs help with the resource allocations, like this is the land or the crop types, or also involving with the deployment of the application in a particular farm, and also funding, which is really important for the farmers to get the system. And apart from that, we are the developers and the idea creators in this system. So basically, until now, we have done the design, but the rest of the thing would take around 5 to 6 months to basically analyze the data and get the appropriate model into place for farmers to leverage their business activities and decision-making systems. So we are going to collect the data and do a bit of data analysis and bring out an artificial intelligence model and deploy the platform in the farm, so in the environment, to understand and get the feedback. So what we see as benefits in the system is, first, it improves agriculture productivity, which was the main problem we analyzed in our first slide. And we could save water efficiently, which is the second important problem. Well, according to the data, according to our research, water wasn't a great scarcity in Ghana, but it is, we could save water efficiently in the other manner. And we could also overcome manual inefficiency by the farmers to keep using the app every time, every day, every minute. Instead, they get notification about saying, okay, this is going to happen this time. The farmers just gets the information, which is absolutely the goal of the app. And at the end, it's going to predict environmental factors, which can help farmers to decide on their crop production and their business, and also their decision-making strategies. And this is a small prototype or design we built. So to understand, this was done by Vignesh, to understand how farmers can use it. So every farmer will have their own account or own registration done. Based on the account, they can select each of the 3 given options. So irrigation app, reports, and factors. So when you go to the irrigation app, it will give you the, basically the goal of the irrigation app is to give you the next predicted irrigation time, which is done automatically by the system. So it'll give farmer the information, what are the factors involved, like the seasons, the water needed, and the crop type, and what is the crop maturity, which day is the crop being grown today. Is the 34th day, and the rain probability as well. And the farmer can also have a small leverage of modifying the time, but which is not really necessary. But we are just given the that application to make sure they get that application instead of being automatically done. And then apart from that, we have the report section in the third image, which is basically gives you the various reports of what has happened over the past few days or past few weeks or past few months for the irrigation which has happened, and how are the crops being affected, what are the most crops grown, and all the various analysis. And also the factors based on the reports are given in the last one, which is basically the soil type factor, the crop types, the various environmental factors like the rainfall, humidity, and temperature, and also the season. But apart from that, we also are concerned with the indigenous knowledge. So we give a farmer a particular feedback form, or somewhere they can bring their factors inside, like they can bring their knowledge inside to add into the system, and we can also update the algorithm or tell the AI learning model to take use of farmers' indigenous knowledge to build the system as well. So our future work would end up developing the application, collecting data from sensors, and also discussing with the local people and validating the data. And after that, we'll be training the AI model, and we'll be testing it in the system, in the environment, and we'll be collecting feedbacks from the people in and around the place in the region. And furthermore, we'll be making improvements. So coming to the end, what we learned from this particular project, all from the course, was basically the teamwork, everyone far away, and we ended up doing a great work in collaborating, and we had our time schedules right on right on proper times. And also we were able to analyze various problems in rural areas. It was not just about developing the application, but also we were much more able to understand what really happens in Ghana in terms of low resource environments. How are the technology used there? Is there Wi-Fi regularly used, or are they able to do some consumption in water or not? I mean, there were a lot of, everything is not same all over the world. So we were able to understand the difficulties in the region as well. And local people knowledge were really wise enough to give us more inputs to our system as well. And I would end up with a small conclusion talking that AI can be, in terms of knife can be used for cooking, so, and crafting. In the same way, AI can be used for better purposes, and we are the creators and influencers. It's good that we keep using it for the better and for the humanity as well. Thank you.
Thank you, Srinivas, for a nice presentation. Very good. Applause. So I'm asking the audience if you have some questions to group number 4. Very, very nice and very complete and an interesting project. So do I see any questions? Well, I can read some comment. I think this comment. Congratulations, everyone. I enjoyed the presentations. This is from Sita. And I see the full value of the course. The challenge was in how to create value from the diverse background and expertise of team members. The outcomes we saw depended mainly on the balance. I have seen illustrations of multidisciplinary research, putting oneself in the shoe of the community members, seeing the worldview and feeling their pains. Well, this is very nice. That is from Prof. Nara. That is very nice for the teams. So thank you, Prof. Nara. So I don't see any questions and I don't see any hands raised. Are there any? Let me see. Wendelin, do you have a question?
Yes, thank you, Anna. Hello, everybody. My name is Wendelin Tuip. I'm a colleague of Anna and Hans. And it's very nice to be here and see all these presentations. So thank you for your presentation. Very interesting. It seems quite ambitious, your this system. And what I can get, but maybe you can confirm this or maybe deny. It seems that it's dependable upon quite a lot of data. And is it easy to access? Is all this data that you would need for the creation of this app, is that accessible, you think, or?
Yeah, So yeah, as I told you, we have Gideon helped us in contacting with the IoT company, and they said that we can give you data for it. And apart from that, that's also a problem when you talk about scalability or accessibility. Yes, we can only narrow to the commercial farmers where they already keep using different kinds of irrigation, and where they have the access to IoT data or the sensors which can be placed in their farm. But when it comes to other farmers, the only solution is to educate them and train them how the system can be used and give them the trust behind the system rather than just jumping and telling this is the system for you. So this is the solution we are trying to head to. Yeah, we have a narrow stakeholder or narrow goal now.
Okay, thank you. Interesting. Thank you for your answer.